Okay, hello and good morning, everyone. Thanks a lot for coming here today. I know it's too early, so I hope everyone has a coffee. Does everyone have a coffee here? Oh, are we ready? Are we awake? Good. Can you hear me good back on the back? Great. So thanks a lot for coming. We're going to talk about cloud-native developer environments and all the new challenges that we face from moving to a more cloud-native infrastructure. We move to containers, we move to that kind of stuff. And all this change needs also a change in the way that we also develop our code in order for our code to run correctly in this infrastructure. Some things about myself. I'm Antonis. I'm from Athens. I'm a Docker captain and a big enthusiast of the project. I'm an early adopter and user. Actually, was anyone from here to my yesterday talk about Docker? A couple of you, good. So now we're going to talk about, we talked about how you are doing orchestration and that kind of things with Docker and tools like Docker. And now today we're going to talk about how we start developing these applications and how we move towards this direction. I usually code in Python. Actually, you might have noticed that t-shirt is it's from the Django project. And also, I'm the technology lead for a company called Sourceler, where we have created an online IDE. And now we have a new product called Stolos, which actually does exactly that, does cloud-native developer environments for you on demand. I generally like to do many automations. I like to talk about DevOps, containers and that kind of stuff. So if you have anything to do with this, just grab me, and I'll be happy to discuss with you. The important part, what we're going to talk about today. So we will start with the current state in developer environments. We'll see the tools that we're using today and how these tools do some things in a good way or in a not so good way. Then we'll move on and we'll talk about 12-factor applications. Does anyone know what a 12-factor application is? Okay, kind of. So we'll talk a bit more about this. We'll say the nice things about staging environments and the bad things and also the ugly things about them. And then at the end, we'll see what does it mean to have a cloud-native developer environment, and we'll see how you can create one and have one for your company, for example. At the end, of course, we'll have a demo, which I hope it will work today, because yesterday I had some technical issues. But I don't give up. I'll give it another try today. So let's start. So let's see the current state in developer environments. First of all, we'll talk about the problem. The usual, So the usual problem that you see in today's talks is something like this. So you have your developer environment, then you have your CI testing, you name it, environment, where you do all the building and integration testing, unit testing, that kind of stuff. And then the developer job ends there, and it throws it over the wall to the operators to ship it to production. And this has several problems, like the developer does not know how the application runs, and you hear a lot of this. So there's the DevOps solution, where you say, okay, with the wall, we homogenize the teams of the developers and the operators into something called DevOps, and then we have a very good testing and CI environment, which resembles the production environment, and then we can make sure that everything crashes in this stage and not in the final stage. But this solution has also many problems, because if you don't develop your applications for the production environment, then your applications might need a lot of iteration or might create problems along the way. So the actual solution, in my opinion, is something like this. You have to have a very good developer environment so that you develop in the same way that your application runs in production, because that way you're faster, you produce better code, and in general, it's a way of doing things that it's really, really good. So in today's environments, we have something like this. First, we have the developers who are developing in their local machine. That means without a VM, without anything. So you have like 4 developers developing in Windows, and then 2 in OS X, and the guy that's always in the corner who develops in Linux because he likes Linux and all that kind of stuff. And it's almost certain that these environments are not well configured, because if all the environments are not the same, I mean, you don't have OS X, Windows, and Linux machines in your production environment. I doubt it. Does anyone has anything like this? No one. That's correct. So your environment is not configured in the same way as your production environment. Then we use virtual machines as an alternative. So we all have our own operating system locally, but then we have one VM that this VM, resembles as close as possible the production environment. But in this case, do you always have one single machine? You don't develop you don't deploy your applications in a single machine. You have multiple machines. So packing everything in one machine is not always the better choice. And at the end, when you are developing locally, you do not start all your services, for example. If you have like 5 or 6 microservices running for your application, and then you say, the billing service is not so important, I can work without it, so you put one service away. Then you say, the emailing provider that I'm using to send emails, it's not necessary for my development, so you put that one away. So you start removing parts, and then at the end you have a very different state of the application in your developer environment than it is actually in your production environment. But of course, in such situations, there are tools, and the tools in our situation are very good. So you start with Vagrant. Do you know what Vagrant is? Good, almost all of the almost all of the room. So Vagrant is a very nice way to create virtual machines. So in Vagrant, you define the way that the virtual machines will be built, and then Vagrant will do it for you. So very good there. Then we said that we have a problem that we don't resemble in the exact same way our production infrastructure. We might use containers, for example. We might use several VMs. So Docker is a very nice way for starters to have a very good runtime. So if you have the same runtime in your developer environment and in your production environment, which could be Docker, for example, then that's a very good way and a very good step as a start. But then you also need something to define the complete stack. So here comes Docker Compose, for example, where you can define the complete stack. You can say that that this service talks to the other service through this DNS hostname, for example, and that kind of stuff. And then you have a complete environment where you can develop your code. So problem solved, right? I can just, you can continue drinking coffee, and I can go outside and have a nice dog. But this is not actually the case here. And let's start seeing why. So first of all, let's talk a bit more about 12-factor applications. So the 12-factor manifesto is actually a manifesto which was created by the guys behind Heroku. Do you know Heroku? OK, I thought so. OK, so these guys said, OK, we have some beliefs in the way that applications should be created and run. And if you follow these beliefs, we believe that your applications will be scalable, will be more resilient, and will be safer to run production environments. So they just wrote down 12 rules that you can use and follow when developing and when writing application, so that these rules can help you create better apps. The goals behind the 12-factor manifesto, where you can find it in this website here, 12factor.net, is that first of all, you need to have declared the formats. So even if it is just a runtime, you need to clearly declare what is the runtime, for example. If you have a complete stack, you need to declare how the stack operates and how the services interchange and connect with each other. Then you have to have a very good and clean contract between the application and the operating system. So you need to know the API of the operating system, for example, and use it in a clean way, not do any hacks and main tricks. Also, your application should be always suitable for deployment. It doesn't matter if you are just developing. You don't have a state of your application where nothing works. You always need to have a state of the application that actually works and is runnable. Then you need to minimize divergence. This was the thing that we were talking about in the start. Like, if you have a developer environment, a staging environment, or a CI environment, and a production environment, all these environments should act in the same way. You don't have to have the problem. It works in my machine. I don't know why it doesn't work in production. This is not allowed. No. OK? So, and the last thing, of course, is that the applications should be architectured so that they are scalable. It doesn't matter if you have just 10 users a day. You need to create your application so that you can handle maybe 10,000 users, as long as you can put more machines running them. Actually, this was a very good manifesto, and we'll see some of these things that affect development, because most of these things affect how you architect your applications, but and not just how you develop them. So let's see the dark side of the moon. First of all, you need to make sure that your developer environments are quick and easy to create. So is anyone here who would be happy to create her developer environment like 4 times a day or 5 times a day? Usually not, because this is a very painful and very time-consuming task, but this should not be the case. Also, there should not be divergence between your developer environment and the actual production environment. I know that you cannot have many 1,000 servers in your local machine, for example, for developing, but you need to have a way, a scaled down, but the same pictures, but in a scaled down way in your local machines when you are developing. And also, it's very important that you have disposable developer environments. When you are developing, you might, for example, test something new, try a migration to the database, or do something crazy. You never should think about, oh, how I'm going to undo this migration, or oh, okay, let's Google how do you MySQL delete a row from delete a column from the database. You should not have these problems. You should know, okay, I did something bad. My developer environment is not perfect now. I will just delete it, and then I'll create a new one. And this has actually direct resemblance with the first one, because if your environment is quick and easy to create, then it's easy to dispose and throw it away and create a new one. So because we have many problems like this one, then there's a common solution that we start to use. Does this mean anything to you? OK, let's have one staging environment for pre-production, and then let's have one for the developer branch, and then let's have one for each feature branch or each pull request, for example, and then let's have one staging branch for each developer, and all that kind of stuff. Staging environments are very good for testing and that purposes, but they're not good to have like 10 staging environments like for different purposes. You need to know why you need staging environments. So in general, staging is great, but it's consuming time and money. It needs maintenance. It needs someone to know how to create these environments. It needs someone to deploy to them. It needs, you need also hardware to run them. So because they're not cheap, you have to know why you're using them. Also, usually these environments are either incomplete. You say, okay, remember the story about the billing service, let's not have it here, or the email service, let's not have it here. But if you put pieces away, then you have a staging environment that's not perfect and is not resembling 100% your production environment. And if you try to pack everything, and you try to pack them everything times 10, for example, for 10 staging environments, then you go back to bullet one, where it needs time and it needs money. And then, if you have staging environments which are used throughout the development cycle, then you have the common case of developers being locked out. Because, oh, I'm testing something on the staging environment. Can you please wait? OK, it will just take 5 minutes. It takes 2 hours. Then for 2 hours, the other developer either does not have something to do or needs to switch and do something else to begin with. So if I'd like you to take something out of this talk, it would be that the staging environments are very good, are very important, and you have to deal with that they're just for some specific reasons. They're good for testing before you deploy to production. For example, if you need to have some safety, they're good for example, to do stress testing, because you cannot do this in your developer environment, and you want to throw some traffic, for example, to the staging environment to make sure that this new function that you wrote does not break everything when under a lot of load. And also, it's good for having an internal version of the service. So let's say that you have a 2-week release cycle. You can have a staging environment resembling the actual development and the dev branch. And then at the at the end of the 2 weeks, you can push this branch to production. But it's just these reasons and not anything else. So let's go to the fun part. We talked about cloud-native developer environments, which are fun, but why are they fun? Let's see the things that they can do for us. First of all, cloud-native developer environments are managed. When you make them, you should make them in a way that developers do not have to care about them and prepare them and do anything. They're managed. If the developer wants a developer environment, she should just click a button, and this developer environment should be ready for her to start developing. So that's one thing. Also, you start treating developer environments like cuddles and not like pets. So for example, your servers, you might have 10 servers. You want 2 more, you just take 2 more. You don't have load, you delete them. It should be the same thing about developer environments. You need a developer environment to start working on a feature. You should click a button. the developer environment would be ready for you, you'll start developing, and then if you don't need it, you just throw it away. You did something, say the environment, you don't want it, delete it, create a new one. This should be the way that you should treat developer environments. You should not, come every morning to the office and say, okay, are you okay, my computer? Please, 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 don't crash everything again. I don't want to do it from scratch. You should not care about this. You should be just like, okay, I want to develop. Click, everything ready, and start doing stuff. Then, the cloud-native developer environments that live in the cloud, actually, have a shared cluster. So you can have easily and shared state. Let's say that, for example, you need to build a time-consuming container. Then if one developer builds it, then the other developer can leverage the cache and have quicker builds, for example. So if you are the early guy, you're the unlucky one that gets to build the whole container, but the one that comes maybe later to the office gets the container for free. Also, you have quick data fetching. Let's say that you want to test with your production data. Then each developer should download in her computer like 5 gigs of data. This is not always the best case because you have slow connections, all developers want to download at the same time. This is a bit cumbersome and it's a bit unhappy for the developers to do so. So if you have a shared cluster, then the data is in the cluster, it's downloaded once, and then all the developers can leverage it and use it and start developing right away without wasting time. Last, but definitely not least, is the accessibility. So, in general, developer environments should be easy to use and accessible. You don't need to create a developer environment and then, waste, maybe change the computer. For example, let's say that you want to work from office and from home, and you have different computers. Then you have to do the same setup in 2 different computers, and this setup cannot be ported very easily. If you have a developer environment that lives in the cloud, then all you need is just an editor, and you can just start coding right away. I mean, I'm pretty sure that you need some tools like Git or maybe some CLI tools that you use in your everyday lives. But even in such case, having these tools is more easier than having to sync 2 different developer environments and always have them right there waiting for you. Of course, in life, everything comes at a price, and everything, I mean, all the good things, they used to say that are either illegal or expensive or they make you fat. But anyway, let's hope that developer environments in the cloud that do not do any of these things. But still, they have some challenges that you need to overcome in order to start using them. So, for starters, it's you need a good way to give access to this environment to the developers. So this environment is now not in her own computer, but lives somewhere in the cloud. So you need to give an easy way to the developer to access it, to run commands inside it, for example, to see the web application running somewhere. You don't have to make the developer always do SSH tunnels, for example, to expose the port. It's not easy. And you have to do it in a good way, so the developer does not waste time in things that before were easy to do. Also, you should not make the developer use completely different tools. The developer is used to using a specific editor, for example, and this was one of the interesting problems we had with Sourceler, where we gave the whole IDE to the developers, and they said, the editor does not do this or that because I'm used to Atom or I'm used to XYZ editor. And then we had several problems with the editor because every developer has her own setup. So I'm pretty sure in the room, if we start sharing which editor uses every developer in the room, then we'll have maybe 15 to 20 different editors. And if we start discussing about the actual setup, like the plugins you're using, or maybe the CLI tools and everything, I don't know, we're 70 people in the room, we'll have 70 different stories to hear about this. So you have to let the developer still use the tools that she's comfortable with, but at the same time, give the whole infrastructure part to the developer for free in a quick and easy way. And also, there should always be an offline fallback, because developers, I mean, we live in the internet. If we don't have Stack Overflow, we're dead. But if someone says, you will not be able to code when you don't have internet connection, we're like, no, please don't do this for me. So you need to have an easy way for the developers to work offline so that they feel more safe and they're more secure about it. So up to this point, do you have any questions or anything you'd like to ask? Because we'll move forward with the demo and we'll discuss some more things in the demo. No? No, it's good. Okay, so if you need to ask anything, just stop me. I don't have problems like this one, and I'm pretty happy. So let's switch back to the demo, and throughout the demo, we'll start discussing all the things that we said throughout the presentation. So give me a moment. Oops. Okay. Is it somewhat okay to see what I'm typing here in the back? Good? Good. Okay. So here, as you can see, I'm using my favorite editor, for example. This is Visual Studio Code. It's nothing special, for example. And in this editor, I'd like to start developing an application. For this example, we will develop a voting application. So we have two different services. One that the end user will go there and vote, and the other that the user, will go there and see the results. So what I'm going to do first is clone the repos. So I'm cloning the voting application code. Okay, we've got good internet connection, that's good. So I have two different applications here. As you can see, one is Node.js, the other one is Python. As you remember, I'm a Python developer, so I know nothing about Node.js. I hate JavaScript. I don't want to see JavaScript in front of me. So I need a way to easily start this environment, and I want to do this without knowing how to, node, run, whatever. I don't know, these kind of things. I want to have something easy to do. So what I'm going to do is use a CLI tool. And I'm going to create a new project. This will create the developer environment for me. Also, I would like to give the specific stack that this developer environment should use, because I know what I want you to start coding in, but I just don't know how things operate in there. So when I do this, I get immediately a public URL, which will be the one that I can access the project, for example. And also, I get the Docker Compose file, which will be the stack descriptor for this project that I started. Then, all I'm going to do is install us up. And then, this will sync the code in my local machine at all times with the remote machine. And after doing so, it will start all the services without me doing anything. So at this point, I just run two simple commands, and I have a remote environment being there for me. And some good guy before me has created the whole stack that this should run so that, it runs in a nice way. So as you could expect in a Docker Compose example, you have an isolated network of all your services. So these services can talk with each other in the same way that they would talk in a production environment. You also have Docker builds, so the runtime of these environments is the same one as in a production environment. I didn't have to do anything about this. And as you can see here, I also have a database, a Redis, and a worker, which are not in my own code because there are some services that are static and I do not want to code in them. I just want them to run for me and do the job for me. So you can see the logs here. So what I'm going to do is open a new terminal and use this simple command. So this command would just, oops, the computer is trying to fall down. It's just going to open the URL that I just started, for example. And as you can see, I have my complete environment here. I can, vote, for example, or I can, open the other services in a very good and easy way. So if I want the result service, and if I'm not doing typos, I can see them here. So as you can see, I got a complete developer environment. I can code in it. It's in the cloud. There's nothing in my computer running at this moment. And I can easily access it through a URL which proxies all the different services. But as I told you, I need to use my local tools because this is the most important part. So if I just want to open the app.py, and then let's say that I want to change the voting options. So the first one would be Voxt Belgrade. And the other one would be other conferences, for example. I just click save, nothing special here. I just go here, I click refresh, and then as you can see, my code changed. So what happened here, I coded in my local environment as I used to do, but this code was transferred to the remote environment. It was executed there in the correct way, and then I got the result in my public URL. So, of course, I'm going to vote Vox Belgrade. Who likes Vox Belgrade? Good. I'm in all the room. Don't worry, organizers. Nice job. Thanks a lot for everything. So as you could see, I could easily run the complete environment. If you access this URL, you can access it too. So it's easy for sharing this environment and saying, OK, you know, I need quick feedback on this design. And send the designer, then just start praying and hoping that she will not have many things to change after the thing. And in this way, I created a very easy to use and quick environment without knowing how do I start Node.js. I did not know how a Docker Compose works. I did not know anything. I just knew, you know, I want to write this stack and start it, and this thing came true for me without doing anything. So the other thing we said about cloud-native developer environments is that they are disposable and easily replicatable. So in this example, I'm going to just create a new environment from this. So I'm going to copy all the folder that I just created, create a new one. For example, let's say audience. I'm going to go to the Vox audience environment. I'm going to hit again create, just with one more parameter. Oops. So this will create the environment for me. But now, as you can see, it's a easy to use URL. So if you want, you can click it on your mobile computer or on your mobile phone. And when this runs, you will actually see the end result. So I'll give it some time to do the same stuff. So you can start with maybe questions or whatever you want. What are you? Where is the configuration file, you said? Yeah, actually, for this service that we have created, for example, we believe that Docker Compose is a very nice configuration file. So, I mean, sorry, the question was, where is the configuration file for this service, correct? So the answer is that we believe Compose is a very good way to describe services and how they interact with each other. So we're using Docker Compose. It's 100% Docker Compose compatible, so you can run it in your local machine if you'd like. But it has some extra markup, which is used in order to, you know, do the special stuff like mounting the code inside the container, that kind of stuff.
The question was, is there a configuration file for a Stolos service?
Yeah, it's a Docker Compose file. It's 100% compatible with Docker Compose. It was a question in the front. Yeah.
How does this work with the Java applications which are managed by Maven and have multiple modules? So how does the deployment work? So how much time does it take? Or because if you have to rebuild the entire tree of jars?
So in Java applications, I mean, if you can build it in a Docker image, then it will run there. So in Java applications have a lot of building time. I've used to be a Java developer before. I'm now a Python developer, and I'm happy about it. But I know that many of the most recent frameworks have auto-reload functionality. So if you change some part of the application, then it recompiles only this file, for example, and then you can have it running. So it's the same way that you would do it in your local machine. If in your local machine you need maybe 10 minutes when you make a change to see the result, then you will need 10 minutes. It will not be faster. But if you have a quick reloader that only compiles part of the application, then you'll have this here. I mean, it's just the same way. I mean, I can even go to, for example, if you go there, just tell me if it works. And also, for example, I could use. I could use a simple command, and now I'm inside the container, so I can run Java, C, whatever. I mean, or Maven build. I don't know. I've forgotten the actual command, but you get the feeling. Other questions? No? Come on, it's too early. Okay. So thanks a lot for coming. We'll be happy to discuss anything from developer environments, developer workflows, or maybe Docker and how you can deploy it to production. Thanks for coming and waking up early, and I wish you have a very good conference. Okay. So yeah. Actually, we have just released a website for Stolos. You can reach it here, stolos.io. And this is my Twitter handle, my GitHub handle, my whatever handle. So if you would like to get in touch, just search me in your favorite social network, and I'll be there waiting for you and happy to talk with you. So have a nice day. Thanks a lot.